Hello guys, hello everyone. Welcome you guys again for this End-to-End AIML session where we're gonna learn everything from a scratch to master. So hope you guys are enjoying this session. So today we're gonna see one more important topic in this data science field, like it is introduction to exploratory data analysis, guys. So hope you guys have watched all the previous sessions so that you can have an understanding of what we are speaking. Okay, so please make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are doing now. Okay, so yeah, guys, today we're gonna see introduction to exploratory data analysis, that is EDA. So EDA is a crucial step in any data science project. It involves a process of understanding the data by visualizing, summarizing, and extracting insight from it. So the major thing of EDA is that you need to have a clear-cut understanding of what the data is given to you. For example, if the data is given to you is a image data, and it is from a medical field, you guys need to visualize in a manner what are the important steps that we are having in that image, whether it is an MRI or it's just like a scan, which part of the scan we are having, whether it is a lungs, heart, like those things. So in order to get a clear cut understanding of what the data is, we need to go for EDA. Not like it is restricted to image, it can go for text also. What kind of text, what is a summary of the text, where we are getting the content from this text, like those things. And if it is a number, so whether it is a proper feature mapping of the number, whether it is related to target variable. So like those things, guys, like whether it is a positively correlator, negatively correlator, or there is no correlation. Like those things, we can easily able to understand by using EDA. EDA is the, like I will say, after data collection and then the data, how to store it and fetch it. Like this EDA is one of the important steps where you guys need to have a clear cut understanding of what the data set is. Yeah, sir, over to you.
Yeah. So, guys, welcome each one of you, and go through all the sessions 5 to 10 times, and do reinforcement learning and information absorption, and then digestion, and then apply. So, go through all our assignments and write in the comment section what have you learned, how you're going to implement the knowledge which you're learning. And today we are going for introduction to exploratory data analysis, which is called EDA, which is very powerful and important tool. We have tools and techniques which we'll use in EDA, and write down in the comment section what have you learned and subscribe to our channels. So let us start. So EDA is a crucial step in any data science project, or I will say in AIML or deep learning, because ultimately AI holistically needs a clean data, a consistent data. There's a concept called garbage in, garbage out. If your data is not cleaned, it is not, you don't do EDA, you don't process it, you don't see and summarize and extract insights from it, and you don't see what kind of data it is. So all those things, if you don't see, what you are giving to the algorithm is just a random data, or just a data which has a lot of garbage values, or then you will not have that kind of performance. So that is why each step is very crucial. So we use EDA for understanding data visualization, summarizing. So we visualize through different plots, scattered plots, histogram, and different tools we use. We summarize, then we extract insights from it. Okay, and that's a major part of a data scientist's work, that he has to extract insights from the data. And that is the major, I would say, part of a data scientist or any engineer or a researcher. Okay, let us move to the next slide.
Yeah, sure. Like, yeah. So, guys, like, as we are saying, it's an important step. Let us discuss what are the importance of this EDA, exploratory data analysis in data science field. First is unleashing the hidden patterns. The thing is, whenever you have a data set, right? When it is a time series data set, you guys need to have an understanding of how the data proceeds. Okay, whether it is in a positive direction or negative direction, or there is any correlation. Consider we are having a stock market price. So there will be three different price, like open, closed, and then something like uh, before closed, or some points like, okay. So when is the stock market is increasing, during open or close? So like that, there will be some trends. So in order to identify that kind of pattern, we use EDA. Next is identifying the data quality issue. So what this EDA will tell means, so how accurate is the data for your model to use? Okay, so that's another one thing, like data quality. Next, information about informing feature engineering technique. So whenever you just project the data, you can able to understand these are the columns that I need. So you can easily pick the columns that you need, and you can derive some unique column which is called as feature engineering. Next, we are having guiding model selection. So we can choose a appropriate model based on the characteristics of data. So I will say one thing, guys. So whenever you need to pick the model, it is not like uh, you need to go for 100% accuracy, or you need to follow any one step. Not like that. You need to apply all the models, and based on the accuracy, or then something like how it performs, not like accuracy, how it performs, you need to select the model. But but for my understanding, as my knowledge, so you need to use the algorithm which better suit for your domain. Do not choose, go and choose the best model. You need to have a data set. For the data set, what is the best model? That is a major thing that we need to have. So that is done by ED. Yes, sir, over to you.
Yes. So again, these are the very important aspects of EDA, which EDA helps to discover the relationship. Okay, anomalies. You need to see the outliers. You need to see anomalies in the data. Okay, and feature engineering, model selection, and ensuring the success of the subsequent data science tasks. So those are unveiling hidden patterns. You need to find the hidden patterns which are not normally in the data. So how you can do that, you can identify hidden patterns by data enabling you to gain deeper insights. You need to find the patterns which are not, and that is the actual work of a data scientist or a researcher, because that is why you need to have statistical knowledge, you need to have algorithm, you need to know which model to use, and then you need to find these hidden things with EDA. Okay, then identifying data quality issues. Okay, inconsistencies, missing values, outliers, and which might affect the accuracy. Okay, that is another aspect. Then we have informing feature engineering, which is uh, providing valuable insights into EDA provides valuable insights, features on most relevant, and how engineering new features for better model performance. So you have to create new features based on the existing data, and which will give again insights, what kind of data and what is the metadata or the sub metadata saying about that particular end-to-end the data holistically. Okay, and guiding model selection. EDA also helps you to choose appropriate model um, on characteristics. What are the characteristics of your data and insights you uncover? So the characteristics and the data, the insights you uncover, you have to select your model according to that, and EDA helps you in that. Let's move to the other section.
Yeah, sure, sure, sir. So, next, identifying data structure and types, guys. I think we have already seen about the programming, right? Now we have an understanding of we need to identify the data structure and types. I think now you guys have understand. Okay, just put it in the command what is meant by data structure and types. Let's see some things. Okay, so whenever you have a numerical value, you should be represented by numeric, categorical, textual, and time series, like those things. So these are the different kind of data structure, or the kind of data that it can have. Okay, and you can see, for example, for the numeric value, we are having something called as a age. Okay, So age is a numerical value. So and then temperature, income, like those things. Whereas for categorical value, so what is my numerical value for the temperature? We will be having values from 25 degree, 18 degree, like those things. Whereas for age, we will be having values from 1 to 25, 30, like those things. And income will be in the range of sometimes it will be IN or in dollar, like those things. Whereas for a category guys, we are having something called as a gender. We will be having male, female, city, like it will be like Chennai or something like Mumbai, like those things. Those are the city names. And then the education level, we are having grade 1, grade 2, grade 3, like that, grade 10. So that those are called as category. Textual means like a product review. So whatever the reviews that you guys give or something like a social media post, below that there is a command. We are writing something that is called as um, texture type. And then time series type where we will be having stock price and then weather prediction, website traffic, like those things. Like based on the some amount of knowledge or evidence we are having, we are saying that it gonna rhyme or this is gonna be the last or profit of the shark market. So these are the different things that we are having for data structures and types. Yeah, sir, over to you.
Yeah, so identifying data structures and types, okay? So we have to identify, it's very important for a project or whenever you are doing after EDA, you have to understand the structure and types of data it's very crucial, guys. So data can be structured, semi-structured, unstructured. So these are different types, okay? So numerical, you have type, numerical, you have description, quantitative data representing value often measured in units, okay? For example, age, temperature, and income. So that can be a numerical data. Categorical will be quantitative data representing groups of categories, so which can be gender, city, educational level. So so the so you need to understand, because based on this you have to choose the models and algorithms, okay? Like linear regression, logistic regression, you have to choose based on the, you need to have this understanding that is it quantitative data or is it qualitative data. So there, because it will be always your problem statement, your data characteristics will show these patterns. So you need to see if it, you find age, temperature, income, all these things. So it is a numerical data. If you find data which contains gender, city, educational level, categorical data. So for categorical data, you have to use different models, different algorithms. Numerical data, you have to use different model, different so textual, again, data composed of words or sentences. Suppose when you do sentiment analysis, so you use textual data, so product reviews and social media posts. So you do sentiment analysis. There you have to use different models. Time series, you use different models because you will have multiple variables there. Data collected over time, often with time stamp. Okay, stock price, website traffic, and it would be very dynamic. So that's why you need to use different algorithm and different models to use right data structures and types. Okay, so let's move to the other section.
Yeah, sure, sir. So next is visualizing data distribution. Actually, it is a part of visualization. EDA along with the visualization so that you can give the more result. So first thing is histogram. Whenever we need to show the frequency of each and every category, we can go for histogram. Okay. So what is a box plot? Box plot, whenever you need to find the outlier, you need to go for a box plot. What is the density plot? It provides a smooth estimation of probability density function of continuous variations. Okay. Thing is, it is used to estimate the probability density value by using this density plot. Scatter plot visualize the relationship between two variables, really patterns and truths. Okay, so the thing is how this scatter plot is gonna work, right? It's gonna find the relationship between two different variables so that it will able to find how they are related, like whether they are positively correlated, negatively correlated, or no correlation. Like those things we can able to find. So these are another way. So it all comes under EDA. So how during visualization we can get more insight, right? So these are some of the plots that we are at. Yes, sir, over to you.
Yes. So data visualization distributions. We have to again, so guys, go through all the sessions, previous sessions, you'll understand. So this would be like going deep into meta level. So here, because then when we do projects and assignments, you'll understand real case studies. You'll understand that why these things are important, and you need to have a concept clarity first before jumping into the application. Otherwise, it everything will look like same to you. Okay. Oh, so uh, data visualization is very, very important because then we understand the behavior of data. Okay. So we use different tools for that. So we visualize data distribution. Okay. It helps to understand central tendency. Why? With central tendency you can understand the how is your data, is it good, is it under underfit, overfit. You have, you will understand that. Spread, you will understand spread, shape, skewed or not skewed, normal distributed, nor, so you will understand all those things. And data variables, common visualization include histogram, box plot and density plot. So you will see the behavior of data, the status, the as it is data which you have collected from primary research or secondary research. So you will see all those things. You will see outliers, you will see how it is normally distributed around the central tendency. Okay, central tendency is a baseline. So whatever is your baseline, how is data scattered around it? Okay, so you'll see. So histogram will show you frequency distribution of normal numerical data, highlighting central tendency and spread. How is your data spread all over the baseline? Okay, then you have box plots summarizing the distribution of numerical data using um, quartiles, median, and outliers, which I already spoke. So you will see all those things, uh, median, quartiles, outliers, box plot will show you that. So you need to remember this, that if I have to see outlier, I need to use box plot. If I have to see smooth estimation probability density function, which is on of a continuous variable. Okay, so you need to understand what is continuous data, what is linear, what is non-linear. So you need to understand all those terminologies. So density plot will provide you that kind of probability density function on a continuous variable. Okay, so understand these things, continuous variable. So this is going to help you. Scattered plot is it will help you to visualize the relationship between two variables, revealing patterns and trends. Suppose when you're doing EDA, so if you want to understand the trends and patterns, you will use scattered plot. Okay, and the relationship between variable. So each and every this tool, I'll say, has its own functionalities, has like all these um, tools, I'll call tools, and they help you to understand the specific characteristics of your data, and then you visualize and you make decision that what kind of model, how is your data, how is it behaving, what kind of changes you have to do. So you'll understand end to end with visualization of data distributions. Thank you. Let's move to the other slide.
Yeah, sure. Yeah. So, guys, yeah, this is what about this session. Like, we have learned about EDA, which is exploratory data analysis, guys. So, I think in order to get a full insight of what is a data set, that is what we need to collection. We have done data collection. We have done. So, next step, the next important step is the EDA, guys. So, you need to have a 100% understanding of what is the data set that you are having first of all. So then only you can do anything. So exploration of dataset is something different. Like you can find the statistical knowledge of it, what's the min value, max value, how they are distributed, like those things. and visualization is comes under EDA, guys. The thing is, you need to find how the data looks. Okay, so that's it, guys. Yeah, in order to get a proper insight from the data, so that you can have a clear understanding of this is what we're gonna do. Okay, so yeah, guys, that's it for this session. Hope you guys have enjoyed this session, and let me know if you guys are feeling any difficulty with the session. Please mention in the comment if you guys feel happy with this session or guys are learning every day. So yeah, guys, hope we will be meeting in the next session. Thank you, guys. Thank you so much.
Yeah, thank you guys. So go and watch all the previous sessions 5 to 10 times, understand them. Each terminology, each concept has its meaning and application, guys. So in mind, first thing should be clear in your mind. So once you have a deeper clarity of concepts, then application is nothing. You can go and apply, like even if your eyes are closed, you will speak like with clarity. But the problem is that we don't get clarity of concepts and we jump into application. That's also wrong. So we need to have a balance of understanding the concept from a deeper level and having that clarity, and then moving to application. Application is easy. Main problem with people I have seen, students, is they don't understand concepts properly and then they jump into application, and they learn by error and trial. But the thing is, uh, if you are suppose 99% clear in concepts, what will happen that you know what you're doing, okay, and you will save years of your time. Otherwise you will do a lot of uh, you will waste lot of time on you will waste your career time. You will not understand, you will make a lot of mistakes, and then uh, you will have a lot of career issues if you directly jump into application. Theory, concepts, and application, they are equally like theory is equally important as your application. Your application is equally important as your theory and concept clarity. So go watch all these sessions 5 to 10 times, absorb the information, digest the information, and then go and apply and solve the world's big problems, create something great, and we'll meet in the next session. Thank you so much.